Howdy folks, episode 6 of some progress on my 1938 Plymouth. Last week we talked about pulling a transmission, we talked about a noisy throwout bearing that I found, and I'd planned to reseal the transmission and change maybe input and output shaft bearing. Well, when I got in there and started to do some work, I discovered some more things wrong with the transmission. Here it is as it sits today, it's completely disassembled. This is my first time going in this deep into a transmission, and I was a little bit intimidated in the beginning, but I'm pretty much confident here that it's going to go back together. I'm going to rebuild it and I'm going to reinstall it again. And let's keep our fingers crossed it's going to work. But it's not that difficult. It's 1938. If you want to learn on a tranny, man, this is a good one to start on, I think. So far, for me, it's been. I can explain a couple things here. I said in an earlier video that I had gear train or bearing noise in first and second gear only. And I didn't hear it in third. Well, I think I figured out why. And you may be interested to learn this if you have a Plymouth or a Dodge or a DeSoto or a Chrysler. And this transmission was used in all those products in the 30s. Right up to like 40, 1934 through 40, somewhere in that range. So we got two gear sets here. Two shafts, I suppose you could call it. This is your main shaft. This is hooked up to your engine over here and your clutch. And power comes in there. And this is the output of the transmission out the end here. There's a bearing there, that's your main input bearing, it's still on the shaft. And this is a counter shaft assembly. This is a shaft here that's pressed into the transmission housing and it holds this gear cluster. They call this the counter shaft, as I mentioned, or cluster gear, because it's got 4 different gears that are all one piece here. Don't know how they machined that, they did nice work on that. That's a nice gear set. So I can explain maybe how the transmission works if there's folks that are interested. Power comes in here. This gear here, this is called input or pinion, input shaft or pinion shaft. This is connected right to your clutch, right there. Power comes in. This gear is permanently fixed here to this one. Constant mesh gear set. Power comes down and spins this counter shaft. It's always spinning when your clutch is engaged. Now, even when you're neutral, the shaft is spinning. When you put it in first gear, you're sliding this gear forward. This is either first or reverse, also known as low gear and reverse gear. You slide it forward and it notches into this gear here, the two set, they marry up and you get first gear. You slide it backwards when you shift, it slides into this reverse idler gear here and it changes direction of the output shaft and then you get reverse. First reverse. No synchromesh. You shouldn't be downshifting this car into first gear or into reverse while the car tires are still rolling, because it's going to grind it. And you get that, you either double clutch or you come to a complete stop. And if you don't, you're going to grind the gear surfaces. And there is some wear on this gear from it happening. I'm going to say that a very large percentage of all these old cars with no synchronizer here on first gear has gear damage right there. Now my teeth are all intact, but a lot of these old trannies, the teeth will be broken right off here or here on the cluster gear because of that. So I've got this kind of propped up. This is where it sits. So let's talk about, we talked about first gear. Power comes in, down here, up, first gear, out. Second gear. This is second gear right here. But it's not locked to this shaft. This gear can spin freely. I'm spinning it now and you can see the shaft is not turning. So what happens is when you put it in second gear, you're actually sliding this synchromesh or clutch gear over towards second gear, and you're now locking second gear to the drive shaft. So power comes in again here, through the pinion gear, up now to here because it's locked, and out the transmission. Third and final gear, what happens now is this gear is fixed to the pinion. This turns all the time. This is the drive pinion gear. Remember, it's fixed. And these two gears are in constant mesh. When I go to third gear, I'm shifting this synchromesh forward and locking it into these teeth. And what I'm doing is I'm locking this input shaft to the output shaft and straight through. So power now comes in, straight out. Now this is still going to be turning because it's in constant mesh, as I mentioned earlier, right here. But no power is going to go through it. And this comes apart in two pieces. See it there? That gear is permanently fixed on there. There's needle bearings in there. You're going to get a look at the synchromesh teeth there. you slide that clutch gear over and you lock it onto these teeth right here, and it becomes straight drive through, power straight through. So again, we had bearing noise in gear 1 and 2. So what shares common between gear 1 and 2 is power, actual torque from the engine goes through this countershaft assembly. But it doesn't in gear 3. Gear 3, this is just spinning, but there's no load on it. Now look at these gears for a second. Understand that these are helical cut gears. They're cut on a 45-degree angle. They all are. And what that does is a helical gear is unique in that the old gears were straight cut across. Those are called spur gears. When you change them over to a 45-degree angle like this and you marry two gears together, you have really good contact surface. The gear has a wider contact area, therefore it's a stronger connection. You can put more torque through there. It also runs quieter. However, the result of that is when these gears have torque going through them, they want to walk themselves apart. There's thrust forces forcing it this direction on this gear, and it wants to force naturally and walk this way. Every time you step on the throttle, torque comes through this countershaft, it wants to walk. So, when this transmission is in the case, over here on each end of the countershaft is a brass thrust washer and a steel washer. Those are both steel, these are brass. Two brass, two steels. The clearance on this inside the housing is supposed to be between 2 and 8 thousandths of an inch. When I checked it before I took the tranny apart, I had 52 thousandths of an inch clearance happening there. So I knew something was wrong. So I pushed it apart and had a look. And I found between the two steel washers, this one over here is worn way thinner. Look at the ridge on it. Do you see it? Can you see that ridge there? It shouldn't be there. It should look like this. And this material is gone. It's been grinding itself apart over its life. And I'm going to guess there's about 45 thousandths of an inch or so missing from that washer based on the measurement I got when I measured it with my dial indicator. So I think, and it's cupped too. You can see how there's a cupped ridge on it. I'm starting to think that my grinding noise was from this countershaft and the extra plate I had 52 thou to move, and it was grinding itself into the washer and it was chewing itself up. So between the throwout bearing, I might have got a bit of noise from there, but in gears 1 and 2, you're putting torque through the countershaft. It's working itself, in excessive play because of the torsional torque forces forcing it that way. Thrust forces. Chewing up the washer, I was getting noise. So I'm going to rebuild all this with new needle washers, new needle bearings, all new clips holding the gears in place, snap rings, new bearings. That's my input bearing there, still on the shaft. I got a new one on the way. Some of the needle bearings I took out over here, you can see them all. They were holding the countershaft in place. And your output bearing is here. This is called the brake housing. There's the output bearing there. I'll push that out of there and change that one as well. And we should have a good, tight, smooth shifting transmission. So there you go. Hope you learned something. I sure did. And I'm quite enjoying myself here. And I think, fingers crossed, this tranny will go back together and work again.